Hey math kids, today we're going to talk about de Moivre's theorem, or something like that. I'm probably pronouncing that wrong, but the thing you see on the screen right now, that's what we're going to use. And it says, find the exact value of the square root of 3 plus I raised to the 8th power. Okay, so if we want to find the modulus of square root of 3 plus I, that's going to be square root of 3 quantity squared plus 1 squared. So that's going to be 3 plus 1, and that's 4. So overall, that's 2. So the modulus of this is 2. Now, if we draw this out, our real part is square root of 3. Our imaginary part is 1. We draw it to there. And so we look at theta right there. And so if we're using this side as 1, this side is square root of 3, that's going to be tangent theta is equal to 1 over square root of 3. And if we think of that on a unit circle, there's two candidates. So it's either this one, which is going to be 1/2 square root of 3 halves, or square root of 3 halves 1/2. Now, tangent is y over x. So we want the square root of 3 to be on the bottom. So since this is y, this is x. This is going to be our choice because it's going to be 1/2 over square root of 3 halves. These cancel and we're left with what we started with. Now that's the first tick mark, which is pi 6. So the argument of square root of 3 plus I is equal to pi 6. So we have the argument, we have the modulus of those different pieces, and so we could write this as 2 cis pi 6. Now once again, that's just equal to the inside of this, not including the 8. Now we have something that looks like this, and so if we raise this to the 8, now it looks like the left side of what we're doing. Okay. And so if we're going to do that, we just take the same modulus, so that's 2. Then we take the exponent, which is 8. And then we do cosine this time. This is cis, not cosine. And then we do cis of n times the modulus. So in this case, 8 times pi 6. Or times the argument, is what I meant to say. Okay. Now, if we do simplify the inside, that's just 8 pi 6. And then we can divide both those by 2, so 4 pi thirds. Okay, and then if we expand that, we're going to get 2 to the 8 times cosine 4 pi thirds plus I sine 4 pi thirds. And if we do that on a unit circle, we estimate this as 0 or 6, 1.5, 3, 4.5, and if we estimate 4 pi thirds, it's going to be about 4. If you haven't seen this estimation before, I'm just estimating pi as 3 to figure out where we're at on, and so we're going to be somewhere in this quadrant. Now what I'm going to do is subtract out all the quadrants before it, so those quadrants are represented by pi, and so if I take 4 pi thirds, subtract it by pi, get common denominators, that's going to be pi thirds, and so pi thirds is our third tick mark, and so that's where 4 pi thirds is. Now if we do the symmetry, this is going to be with the first tick mark, and then it's actually going to be with the third tick mark. So this is 1/2 square root of 3/2, and so it's going to be the same thing, but just negative on both of them. Okay. Alright, now we're going to replace this with negative 1/2, and then replace this with negative square root of 3/2, 2 to the 8, so we have negative 1/2 minus square root of 3/2 I, and that's 2 to the 8, not 28. Okay, distribute this, and if we use a calculator, we'll get negative 128 minus 128 square root of 3 I. And that's going to be our answer for that one.